we are building Voiceless. Today, AI is everywhere. It can talk, write, and even think like humans. But for millions of deaf and hard of hearing people, AI is still not truly accessible. Most AI systems assume you can speak or type, but what if your primary language is sign language? Over 70 million people worldwide use sign language daily, yet there is almost no AI that understands or responds in sign. And here's something important. Many deaf users are not fully comfortable with written English, so even text-based AI can feel limiting. That's why we built Voiceless. Voiceless is a sign-first AI assistant where users can communicate using sign language, not voice or text. It's built to make AI more inclusive, more human, and more accessible. Because communication should never depend only on the ability to hear or speak, and with Voiceless, it doesn't.
Voiceless is a real-time sign language to text chatbot designed to make communication easier between sign language users and non-signers. I will quickly show how it works from the user side, then I'll demonstrate a live conversation, and finally I'll explain what's happening in the backend. This is the website interface. The idea here is to keep things very simple and accessible. At the top, you can see a brief explanation of what the system does. It captures hand signs using the camera, converts them into text, and responds through a chatbot. As I scroll down, the important thing to notice is that the user doesn't need to understand any AI or coding. This button here opens the chatbot interface, which is where the real interaction happens. Now I'll show a real-time conversation. The camera is live and continuously capturing frames. When I perform a sign, the system detects it and converts it into text. As you can see, the detected sign appears here as text. This text is then sent to the chatbot, which understands the intent behind it. The chatbot responds instantly, just like a normal messaging app. So, from the user's perspective, this feels like chatting naturally. But instead of typing, they're using sign language. Now, I'll move to the backend and explain how all of this works internally. System is divided into three main parts: sign detection, chatbot logic, and response playback. Sign detection. First, I'll explain the sign detection module. For sign recognition, we are using a convolutional neural network with a ResNet backbone. ResNet is a deep CNN architecture that uses residual connections, which allows us to train deeper networks without vanishing gradient issues. The live camera continuously captures frames, and each frame is then passed into the CNN in real time. The ResNet backbone acts as a feature extractor, converting raw pixel data into high-level spatial feature maps. This system specifically uses a transformer-based vision model, specifically a DETR architecture, which stands for Detection Transformer. As you can see over here, these feature maps capture important hand characteristics like edges, contours, and finger orientation as well. We also use softmax probability scores and apply confidence thresholding to filter out unstable predictions, right? Predictions are smooth over consecutive frames before being finalized. This approach makes the system more robust to minor hand movement, lighting variation, and background clutter. Once a sign is confidentially recognized, it is converted into a text label which is sent to the chatbot. Next, coming to our Raza chatbot part, Raza allows us to separate understanding what the user means from deciding how the system should respond. The detected sign text is then passed into Raza's NLU pipeline, where the system performs intent classification. So instead of just reacting a word, the chatbot understands the intent behind the sign, like greeting, asking a question, or making a request. Once the intent is identified, the dialogue manager takes over. It uses predefined stories and policies to decide the next best response, while also maintaining context across turns. If there's ambiguity or low confidence, the system uses fallback handling instead of giving incorrect responses. Once Raza generates a response, it is sent back to the interface via WebSocket. Also, additionally, we have made this backend project in such a way that a person can pull our GitHub repo and develop it locally as well. So it's not only up to us, it's always important that we get a whole community We get the support required to build this chatbot furthermore. Also, one key thing over here, the sign detection part that we have built over here can also be used in various image classification projects as well. So do check out the GitHub repo.